I just didn't want you to think it was just Lou Reed. It's also true. On the morning of March 28, 1979, an alarm went off in a nuclear power plant. And then another, and then another. Alarms going off in a nuclear power plant, that's not so unusual, but it's not really ideal. The first alarm was because of a small mechanical failure. That small mechanical failure then devolved into a series of cascading mechanical failures. 1979, Harrisburg, Pennsylvania. Some of us are in the future also. These cascading failures turned into the largest nuclear accident on U.S. soil at 3 Mile Island. And in the hundreds of hours and thousands of pages of government reports that went in to talk about what went wrong, what could have possibly happened at 3 Mile Island to create such damage, $2 billion worth of damage and a lot of radioactive shit in the air. What happened? Well, there were a lot of different contributing factors, but I like the way that Roman Mars describes it on the 99% Invisible podcast as a cascading failure of humans. See, because each of those mechanical failures had a corresponding alarm that had like a sound and a light and a klaxon, and there was just so much sound and fury signifying nothing, that the responders were overwhelmed. They were missing critical information. They were just literally dumbfounded by the amount of noise and couldn't take action. They couldn't resolve the problem. It wasn't actually until 4 hours after the first failure, after that first alarm went off, that a new team of responders came in with fresh eyes and fresh ears, and they were able to process the information, make decisions, and move forward. But unfortunately, it was too late. So this idea of too much alarm noise, too many alarms, that inspired my team, the data experience team, to try to help our customers prevent, if not nuclear, infrastructure meltdowns as aggressively not helped by too many alarms. And we're going to try to solve that problem with data science. Now, I am not going to talk to you today about how to add regularization to the cost function under linear regression, or how to train a convolutional neural network, or how to apply the Peabody principle to your deep sphere of machine learning, because the last one I made up. And the first two, they're just fancy. No. I'm going to talk to you about the other stuff that goes into developing, iterating, shipping, and then supporting a product that uses data science. And I also want to talk to you about what that means when you want to make it successful. And by successful, I mean profitable, meaning it's worthwhile for people to spend money on it because it's valuable. Hopefully, I will inspire you to try the same. So, where do we begin? The first step to making money with data science is to find a painful customer problem, and the second step is to solve it. That sounds a lot like regular product development. What a coincidence. See, before you find your magic data science technique or the latest, hottest artificial intelligence, or you invest in some new research, you actually have to find a problem worth solving, because here's the secret. People don't pay for algorithms. Nope. They pay for solutions. They pay for solutions to things that they feel that are actually painful. So, how do we find that pain? Well, as a product manager, I look at things like, the company market fit and where our competitive landscape is, and then we have to understand kind of where we fit in the world. And just for context, as I use some vocabulary here, I work at PagerDuty, as Maddie mentioned, and at PagerDuty we think about events that come in from monitoring tools that get routed into services as we model them in PagerDuty. Those events turn into alerts, those alerts turn into incidents, those incidents will then, call you, or text you, maybe send a screaming yak after you. Maybe so often that it may feel like you too are at 3 Mile Island. Well, Our customers were telling us that. And so that's where we kind of start, is customer interviewing, empathizing and understanding the customer. Now, customer interviewing can be tricky, right? Because you can ask a lot of questions, and you will hear what you want to hear. You will definitely understand that that idea you had was the right idea. You will walk away, and everyone will nod your heads, and that is not inspiring. Leading questions will get you the answers you're expecting, not the answers that you need. You will not find pain in a leading question. You will find pain in concrete memories that people resonate with. And I really like this book, Interviewing Users to Uncover Compelling Insights by Steve Portigal, because he gave me this framing. Tell me about a time when. This is not a hypothetical situation. This isn't ambiguous. This is something that they remember. Tell me about a time when solving a problem was more painful than it should have been. Well, there was this time that Tiffany was trying to triage a problem we had with our authentication service, but the Nagios alerts were so voluminous that she just turned her phone off. Okay, what do we have? Nouns. Tiffany, authentication service, Nagios alerts. Now we have a shared context, shared vocabulary, and you remember that. They remember that situation because it obviously created pain. Pain that they remember. They remember the postmortems afterwards. They remember the customer impact that happened. They remember the hours lost to doing the interesting work because we were still doing this other work and it took longer than we wanted to. So now we can talk about the next stage. Imagine the ideal situation for Tiffany. Imagine things are still going to go wrong, but what could have happened better? It's a different, more positive way of expressing that pain, and the answers here will guide you. Now, what does any of that have to do with data science or making money? Well, what we're talking about is we're getting closer to the product vision. Product vision is not a mission. The mission is purposefully vague. The mission of my team, the data experience team, was to improve the experience with data. Thank you for that. I wrote it, so I feel very proud. No, but a mission, that's one thing. A vision is a future you can hallucinate to be true. It's so realistic that in this future, the customers that you're serving are living better lives because of you. You built that thing that solved their problem, and now their lives are better. And you can imagine what that future looks like so realistically, it's like watching a movie. Okay? Let's hallucinate. Let's hallucinate with me. Let's reduce alarm noise. So in this future, let's imagine a good place. Now, it's not a great place because you're still going on call and things still break and you still have to fix it, but it's a pretty good place. And in this pretty good place, in this pretty good future, when something happens, something bad happens, I find out about it. Maybe it's like a harp sound. Okay, and I find out about it, and then all of the related symptoms, they gravitate towards that one problem, but I don't have to find out about each of them. I find out about the one. And then simultaneously, if another separate, distinct problem happens, I find out about that one. Bells ringing gently. And then all of the symptoms related to that, they also gravitate towards that one, like a magnet, problem magnet. So now I'm able to see that my customers are able to focus on the problems at hand. They find out about the problem when they need to, and they can keep track of the changing aspects of that problem as it continues. Now they have a lot more time to solve those problems. They may even have the time to prevent those problems from happening again. They're not wasting quite as much time as they were before. Well, maybe those problems go away. Now they have new problems because they shipped new code. If we would just stop shipping new code, I swear, there would be fewer problems. And no one listens to me. No. So now they've got new problems. And now when those new problems come up, they also find out about them. And similarly, all the related symptoms of those problems, they kind of coagulate together without having to manually configure or tell a system, hey, this is what the new problems are going to look like, because I am an oracle and I know the future as if I am some sort of God being. No, that is not true. Why this ambitious, lofty expansion of a vision? Because we were hearing about this pain.
See, while people were describing just alarm fatigue and alert noise, and that was the biggest bully in the yard, that was the problem that stood out over all their others. We're hearing these stories, tell me about a time when. And they would tell us about a time when they tried to write a bunch of rules, or they tried to write some scripts, or they would kind of hack stuff together, and then people would apologize. I love when people apologize. I tried to do this thing, it didn't work. I know, I'm with you. So the cost of actually trying to solve their own problem was itself creating a new pain. So in this ambitious vision of the future, what if we could have a system that dynamically adapts and predicts based on data over time to do the right thing? What's that? Data, predict. I think we're talking about data science. Okay, so I'm going to challenge you to think about something you're working on right now, something you're trying to deliver for people. How can you blow their mind? How can you make the vision that you thought you were working on ambitious and incredible? A dynamic system that updates. So data science, that's using statistics and looks at patterns in the data over time. And within data science, we've got machine learning, and that creates predictions. And what does that look like as an experience? It could be that you're predicting a value, you're making a recommendation, you're suggesting a next action, instead of offering up to your user an endless number of radio buttons. You know, there's this joke that anytime you see a radio button, it's just a product manager who couldn't make a decision. And I've designed some radio button interfaces in my day, so I know. It's true. But perhaps instead of offering those endless configuration options, you could just do the right thing. Isn't that what it feels like when it's a seamless experience? Don't you already know my name and shipping address? I've already written it down. That is the kind of experience that you can provide all over. So I'm going to challenge you to think about your vision while I talk to you a little bit about data science. I know I actually promised not to talk about data science that much, but the world is full of betrayal, 1. 2, I think we can all stand to be a little bit more literate. And 3, cute pictures of ducks. So, old. Okay, so within data science, an oft misinterpreted word, there is a field called machine learning. It's where we get predictions. Within machine learning, there's unsupervised and supervised machine learning. We'll ignore unsupervised for now because it's unscrupulous. It doesn't pay attention. Supervised machine learning, that's where we'll start. Supervised machine learning is when we make a prediction and we can evaluate how right we are because that thing happens. And then we can see if our prediction is right or wrong. An example of supervised machine learning is supervised regression, where we predict a value, we predict a continuous variable. So, for example, I could predict what percentage of the time Cubs player Javi Baez is going to swing for a home run when he's up at bat. And I would predict 100% of the time. And I would be right. Javi. I could predict what the rent prices in San Francisco, where I currently live, much to my dismay, are going to be in 6 months. And I would say $11 billion, and I would be right. I would be right again. Supervised machine learning, supervised regression. Okay, so then the other kind is supervised classification. This isn't a value you can compare. These are different categories. So an example you're familiar with is your spam filter in your inbox, right? There's classifying things as either spam or not spam. The email from me, the email from your friend, I'm not asking, I get it. Okay, so here in my duck classifier, I'm looking at animals that are ducks and that are not ducks. And I've got this data set that I'm training my supervised machine learning algorithm to see. There are examples of adorable animals, and when I introduce a new one, my machine learning model says, in fact, it's a duck. And I'm right. So one way you can decide in your ambitious and lofty vision of the future if you're going to be using machine learning, and this is helping you narrow down the universe of potential, is this Mad Lib. Using some data, I can predict some value. Using what I know about alerts and events as they come into PagerDuty, I can classify whether they are part of an existing problem or if they're a new problem. And those same customer interviews, those told us whether or not they would be supervised or not. And in fact, customers said, yeah, there's a right answer as to whether they were all part of that problem or not. So we knew it was supervised. Existing problem or new problem. Classification. We have now narrowed down, just with our thinking about customer empathy, what kind of problem we're trying to solve, and the experience validates the way that we're going to now pursue our development. We've gotten to supervised classification. Now, how are we going to narrow down this further? Let's think about how this supervised classification is going to manifest itself. This prediction can either be taken as a suggestion or as an action. Let's take back to 3 Mile Island. Ooh, it's very noisy in here. Do you want some of these maybe to be put in together in one place? Sorry, what? Sorry, what? No. A suggestion in this case would be a bit of a cascading failure of humans. We're going to have to actually take an action. Just like your spam filter immediately separates what is spam and what is not spam. That's what's valuable to you. So that means that we are now further narrowing down the universe of possible techniques we can investigate. This is before we've even gone on any research, any prototyping. We now know that within supervised classification, it's going to have to be an algorithm that performs quite fast. It's going to have to be able to operate on a limited amount of information. It's going to have to operate within our SLA and maintain our resiliency standards. Okay. So we've figured out our product vision based on our customer interviews, and we have narrowed down the field to a certain number of techniques. And this is the part of making money with data science that feels like failure, because you will fail a lot. Prototyping looks like failure. You're going to try a bunch of different techniques against these data sets, and the data sets themselves, it's going to be kind of a burden to get to. You have to find, prepare, normalize, figure out how to use, and then evaluate the data. This data. What is this data? Supervised classification requires examples of what you're trying to predict. It's called a labeled training set. So you need examples of spam and not spam. You need animals that are ducks and not ducks. And you need more than like 2. It can't just be like a moose, a hedgehog, a duck. I'm done. You need a little bit more. So what could we do? The data set we were working with had 350 million incidents, 589 million notifications to 1.7 million people. Awesome. Okay, but labeled data means that I need examples of what I'm trying to predict. So I need examples of when alerts are coagulated together into incidents. And PagerDuty had this feature where people could manually merge incidents together, thereby creating an incident with multiple alerts. All right, let's find that. No. 28,000 manual merges? That is less than 1/100th of 1% of the data set. So we gave up. No, we didn't give up. But just for reference, anybody here remember the Netflix challenge when they said, can anybody make a better recommendation algorithm than that? Okay. The size of that data set, the size of that labeled training data set, how many records do you think there were in there? Sorry? 1 billion? That's a big guess. Anyone else? What's that? 100 million. 100 million? Just laying around? Data they could just toss any Jill Schmidt on the street? Here, you get some data, and you get some data, and you can have a training data set. What, are you kidding me? They don't even use the result of that challenge anymore. They don't even use that data anymore. Ooh, Netflix. Because they have better data now. Because at the time of that challenge, their primary business model was shipping DVDs to somebody's house, and then they would say whether they liked that movie with a 5-star rating. So Matt Stratton would say, of course, Oscar-winning movie King's Speech, that's what I'm going to use to prepare, and I loved it, 5 stars. But now that we have streaming media, Netflix's business model has shifted. Netflix now knows what Matt Stratton did to prepare for today. Let's watch Blues Brothers on repeat, right? We have dwell time. We know whether you actually watched a movie. We know whether or not you rewatched a movie or you bailed out halfway through. Me, I'm more of a Ferris Bueller's Day Off kind of gal, to be honest. And that is now how they can infer much more information than what you say you do is what you actually do. So, can we find the data elsewhere? Well, we asked our customers. Tell me about a time when you recognized that their 4 simultaneous things were actually part of the same problem. How could you tell, and what would you do? In an ideal situation, when you're onboarding someone new to your team, how do you tell them to figure out if all those things coming in are part of the same problem? And then what would you tell them to do? Behaviors, something we could find in the data. Now, this is something that we like to call collaborative filtering. This is a study of collaborative filtering. The authors of this paper, Collaborative Filtering for Implicit Feedback Datasets, talk about building a recommender for TV shows. Recommenders can infer user preferences from the more abundant implicit feedback, which indirectly reflect opinion for observing user behavior. And this paper talks about the caveats and advantages of using that kind of implicit user behavior instead of what somebody will explicitly tell you. Now, given that, we were now able to analyze that previous data set and see more of that action. And in those customer interviews where we were asking about their behavior, they said, you know what? Like 9 times out of 10, if the same thing comes in that service and it's like within a minute of each other, it's probably the same problem, right? Or maybe within 5 minutes of each other. Time was the biggest indicator for people to tell whether something was actually part of the same problem. And so we gave them kind of a baby miniature version of that vision, radio buttons. I know it. Right? And it was a timer. We said, okay, on a PagerDuty service, you can set a timer, and then for the duration of that timer, as new alerts come in, they'll all get automatically grouped. And this allowed people to start interacting with the beginnings of that vision, and we could start finding the other parts of the experience that would dictate what people expected as alerts were going to be automatically grouped, which was a big change from how people experienced it before. And we learned a lot about what kinds of things we should do, including what to call it. We started calling it simple alert grouping. And then we called it basic alert grouping. And now we call it time-based alert grouping. Those are great at names. So now we have an ambitious vision of the future with a specific customer pain. We have a significant labeled data set that's going to serve us towards our narrowed down universe of algorithms. And we've got a kind of prototype of a vision on what the experience should look like. Now we just have to iterate against those, measure against success, and then ship it. Easy peasy. Now, what does measuring for success look like? Now, what a lot of people will talk to you about is measuring success of your machine learning algorithm with accuracy, precision, and recall. How often were you right? How often could you have the opportunity to be right that you didn't catch it? And in order to tune those parameters of accuracy, precision, recall, you can add complexity. Right? And the more complicated something is, the harder it might be to understand for the person writing it, developing it, and supporting it. Maybe the harder it is to guarantee performance. But the other thing that is harder, the challenge about complexity, is that it also compromises explainability. Explainability is kind of a hot topic in data science right now, but you all experience it. The cost of a consequence describes how explainable that prediction has to be. Let's say that my pump-up music is going to be the thing I imagine myself singing on top of a float as I lead the city of Chicago into a song and dance. What is that song going to be? Spotify makes me a recommendation. What does it cost me to evaluate if that is, in fact, the right song for me? It takes me about 15 seconds. I say yes or no, and I move on. It's not a big cost of my time. But let's say that OpenTable is now going to make a recommendation for where I should go to dinner tonight to celebrate this, my first DevOpsDays. What if OpenTable was wrong? What is that going to cost me? It's going to cost me a couple hours, and the average OpenTable bill is $200. An opportunity to eat dinner in one of the best cities in the world, in one of the best restaurant cities ever, and you're going to give me that recommendation? You better explain why. Because the cost of you being wrong is harder for you to verify. Your consequences are more important. So it has to be explainable, which might mean that the algorithm that's generating that prediction has to be simpler, has to compromise on complexity to afford for explainability. Now, that is a lot to balance. We've got to think about performance and accuracy, the ability to scale, the ability to be resilient, how we can therefore explain it. And when we think about explainability, it's not just to the end user, it's also to the people who are actually selling it. I'm a product manager, but I don't sell software. The salespeople sell software. Customer support software. Success, they have to understand it also. If you want to make money with your product, you've got to help the people who do the selling understand the value of that product. Imagine what it's like beyond all the normal enablement assets that we have to create a demo environment that by nature changes constantly over time. How are you going to enable the people in your organization to demonstrate that incredible vision that you dreamed up like some minutes ago. When you figure that out, you let me know, because I am working on it. There is a lot more to the story. What is it like to provide monitoring for something that's non-deterministic? How do we provide scale? How do we automate the processes of data collection? What were the open source projects that we invested in? And I'm happy to talk about it in the hallway, but I want to leave you with this. Given a well-articulated customer pain, the right data and a thoughtful design can create an incredible experience. And it may or may not use data science. But if it does, data science is not going to be the only key to your success, and data science can do a lot. It can predict values, it can see things that are different from other things, it can tell you what things belong together, it can rank and show you what's relevant to what you think right now. But there's a lot more to it. You have to be creative, you have to really learn and understand your customers, you have to design thoughtfully for the entire experience, considering explainability, that people, in order to use and buy your product, have to trust and value it. You're going to have to experiment and define metrics of success. You're going to have to iterate time and time again. You're going to have to then, finally, actually ship it. Thank you. Before this, did you really know what I was?